All right, back again for section 6.2 of our geometry book. This is properties of parallelograms. Now, I drew a diagram here, which hopefully is helpful in terms of understanding how polygons all sort of fit together in the family tree. So up at the top here, the most general term we have is a polygon, which is just a multi-sided figure. And of course, off of polygon, we can have any number of multi-sided figures. We can have pentagon and octagon and hexagon and heptagon and decagon and dodecagon and etc. But we are actually not dealing with those in this chapter, except to be aware of them and their names. What we're going to do is focus in on a particular kind of polygon, which is the quadrilateral, which is a four-sided figure. In particular, we are going to look at a specific kind of quadrilateral, which is a parallelogram. And in the course of looking at parallelograms, we will look more specifically at a rectangle, a rhombus, and then the perfect combination of the rectangle and rhombus is the square. We will also in this chapter be looking at a couple of other quadrilaterals besides the parallelogram, one of which is the kite, which looks something like this. Okay, so it has these two sides congruent and these two sides congruent. And we're also going to look at a trapezoid, which has two sides parallel, but not four sides parallel. Okay, section 6.2, I'm going to take this off, and we'll look at properties of parallelograms. Now, parallelogram is a four-sided figure which by definition has two sets of opposite sides that are parallel. So in other words, these two are parallel and these two are parallel. Now, you may recall back when we talked about parallel lines and transversals, we had various kinds of angle relationships. For example, alternate interior angles were congruent, alternate exterior angles were congruent, and in particular for our purposes here, I want to remind you that corresponding angles, two things, consecutive angles and corresponding angles. Consecutive angles were angles that were one right after another, also called consecutive interior angles, as in x and y. And you may recall that the sum of x plus y, if these lines were parallel, was 180 degrees. So that's one of the things that you're going to discover because you have parallel lines here and parallel lines here. We're going to be going back into chapter 3 to recall some of the things about parallel lines and transversals. If these two are your parallel lines, then this is a transversal, and so this would be two consecutive angles, which are then going to be supplementary. So, a variety of things that you'll discover here that go back to these properties you learned about parallel lines. But first, let's look at some of the specific properties of parallelograms. A quadrilateral is a parallelogram. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So this side is congruent to this side, and this side is congruent to this side. So, if it's a parallelogram by definition, that is, these two sides are parallel and these two sides are parallel, then you also know that these two sides are congruent and these two sides are congruent. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So this and this are going to be congruent, and this are going to be congruent. And that, by the way, has to do with the parallel lines that we were talking about earlier. Quadrilateral is a parallel. If it's a parallelogram, then its consecutive angles are supplementary. That's what I said earlier. This was x, this was y. These two angles, consecutive, one after another, are supplementary. They add up to 180 degrees. And the fourth one here, because this is getting messy, and I'm going to redraw it here. The fourth one of these properties is that the diagonals if a quadrilateral is a parallelogram, then its diagonals bisect each other. Therefore, this is congruent to this, and this is congruent to this. All right, those are your 4 theorems for this section. Now, let's just take a look at, I'm going to wait and do the proofs later on after we've gone through the mechanics of these sections. But let's just take a look at some of the things that you run into here. These are going to be little algebra problems that of the type you've seen many times before. But for example, let's say that you have a parallelogram here. And that's not a very good one. And we have the diagonals which bisect each other. So, if, for example, this was 2u plus 2, or I'll make it 2x plus 2, and this was 5x minus 10, then you know that because these diagonals bisect each other, this is congruent to this, and therefore we can say 2x plus 2 equals 5x minus 10. Subtract 2x, we get 3x, equals, add 10, we get 12. So divide by 3, x equals 4. Okay, that's the type of thing that you'll be doing with these. Another one here would be if you had a parallelogram in which you were given some angle measures and you were asked to, you were given some letters for angle measures, C degrees, D degrees, A minus 10 degrees, and a plus, B minus 10 degrees, sorry, B minus 10 degrees, and B plus 10. So you're asked to solve for all these variables. Well, it's actually not that hard to do because you have B and B right here, and you know these two angles are consecutive, therefore they are supplementary, so B minus 10 plus B plus 10 equals 180. The 10s cancel out, plus 1 minus 1, and we get 2b equals 180 divided by 2, and b equals 90. So this is 90 minus 10, which is 80. This is 90 plus 10, which is 100. Now, you know that these two are supplementary. You also know that opposite angles are congruent. So either way, this one has to be 80, this one has to be 100, and there's your answer. All right. I think for the moment, skipping over the proofs in this section for now, I think we'll stop this and move on shortly to section 6.3.